Hi, we hope we are doing well with this simple calculation, and now we want to address a topic known as acid-base titration. We are going to first of all talk about volumetric analysis, and volumetric analysis, as the name suggests, is derived from the term volume. So it's a method of determining quantities of chemical in a reaction. The amount of substance is determined by measuring the volumes of solutions. The apparatus used are usually pipettes and burettes. Examples of volumetric analysis is titration, and there are three types of titration: direct titration, back titration, and redox titration. In direct titration, two solutions are usually reacted in completion. So one solution of known concentration and volume, and it is referred as standard solution, is reacted carefully with another of a known concentration, referred as analyte, to determine its concentration or RAM of the element or the percentage composition of constituent element of that analyte. A Form 3 student wanted to determine the equation for the reaction between sodium hydroxide and hydrochloric acid. So, using a pipette, she transferred 25 centimeters cubed of 0.1 molarity of sodium hydroxide solution into a conical flask. She then added 2 drops of phenolphthalein indicator, and a clean burette was filled with 0.1 molarity of hydrochloric acid, and the initial reading read and recorded in a table. Note, this is usually done below the meniscus. She ran the acid solution in about 1 centimeters cubed portions, swirling the liquid in the conical flask after each addition. After several additions, the pink color in the conical flask started disappearing on shaking. This change of color happens near the end point, and this is when she started running the HCl in dropwise until the color of the solution changed to colorless permanently. So the final reading was accurately read and recorded. She repeated the experiment after discarding the first content in the conical flask, then washing and rinsing it thoroughly. So the table of the titration of sodium hydroxide with dilute acid is given below. So this is the final reading. We have the final reading of the burette, we have the initial reading of the burette, and then the volume of the acid. So to get the volume, we get the final reading, you subtract the initial reading, and the first case it was 24 centimeters cubed. She continued from 24 up to 50, the capacity of the burette. Then the volume was 26 after the subtraction. Then she refilled the burette with the acid. So she started from 0, then ran all the way until the color changed to pink, colorless permanently, and she got 25 centimeters cubed. So the average of the acid used was 25.0 centimeters cubed after adding the 3 and dividing by 3. So the questions: what was the volume of sodium hydroxide used in the titration? The volume is 25 centimeters cubed. This is usually the volume of the pipette. Sometimes this question will not be tested, but it is good to know as a student that the volume of the acid or the volume of the hydroxide or the base is the one that is in the pipette, the volume that you pipetted. 2. What is the volume of the hydrochloric acid that reacted with 25 centimeters cubed of 0.1 molarity of sodium hydroxide? This one you get it from the table. content in the burette. So we got as 25 the average titer of the HCl. 3. Determine the number of moles of sodium hydroxide. Now, if you want to determine the number of moles of sodium hydroxide, remember the volume of the pipette and the concentration or the molarity of the base was 0.1. Therefore, this means 0.1 moles are present in 1,000. Therefore, represented that way. So what about 25 centimeters cubed? You cross multiply 25 times 0.1 divided by 1,000 to get the number of moles as 0.0025 moles of sodium hydroxide. We proceed to the fourth question. How many moles of hydrochloric acid are there in the average titer? We were given the information about the HCl. In this case, we have 25, the average titer from the table, and the molarity also we are given. So in this case, the molarity will give us this interpretation, 0.1 in 1,000. So what about in 25? So in 25, you cross multiply 25 times 0.1 divided by 1,000, and the centimeters cancel out to get the 0.0025 moles of HCl. So now we have the moles of HCl and the moles of sodium hydroxide. So fifth question, what was the whole number mole ratio of sodium hydroxide and HCl? So we put down the number of moles and then we divide with the smallest value like we did in the empirical formula. So when you divide with the smallest value, you get the mole ratio as 1:1, meaning the base and the acid reacted in a ratio of 1:1. 6. Write down the equation for the reaction between hydrochloric acid and sodium hydroxide. So this one we apply now the mole ratio, where we have HCl 1 mole, sodium hydroxide 1 mole to produce 1 mole of sodium chloride and 1 mole of water. This type of reaction is known as neutralization reaction because salt and water are formed, only salt and water. Question 7. Write down the ionic equation of the neutralization reaction. So in this case, the HCl is in aqueous, sodium hydroxide in aqueous, then sodium chloride in aqueous, so they can be written in ionic form. So when you write the ionic form, there are those ions appearing on either side of the reaction, so they are cancelled out, and one of them is not chloride. We have sodium ions which are appearing on this side, and also we have the chloride ion. So when they cancel out, you get this one as the ionic equation. Standardization. What is standardization? In standardization, we try now to determine the concentration of one of the reagent. In an experiment, to determine the concentration of HCl, 20 centimeters cubed of 0.2 molarity sodium hydroxide was observed to neutralize 20 of HCl, the average titer. Before we continue, it is good to notice that in this case it's different from the previous, because in the previous example we were given the concentration of the HCl and also we are given the volume after getting the titer. And then again you are also provided with such information where it had the volume and the molarity. In this case we don't have the concentration or molarity of HCl, so it is good to note that. So A. How many moles of sodium hydroxide were present in 20 centimeters cubed of 0.2 molarity of sodium hydroxide? So we know 0.2 stands for 0.2 moles in 1,000. So what about in 20? 20 times 0.1 divided by 1,000. The centimeters cubed cancel with the centimeters cubed. You are left with the moles. and the number of moles of sodium hydroxide will be 0.004 moles. Write a balanced chemical equation between sodium hydroxide and HCl. So here we'll start with writing the chemical equation so that we establish the mole ratio. So the sodium hydroxide and HCl will have that kind of reaction which is balanced. Then question C, what is the mole ratio of the balanced chemical equation? In B above, the ratio is 1:1. How many moles of HCl are there in the average titer? So since the moles ratio is 1:1 and we already know the number of moles of sodium hydroxide as 0.004 moles, then it implies that the number of HCl will be 0.004 times 1 divided by 1 to get the same value like this sodium hydroxide. Since the mole ratio is 1:1, then we'll find that the number of moles for HCl and for sodium hydroxide will be the same or equal. Determine the molarity of the HCl of the acid. Here we are being asked about the molarity. We know about the average titer and we have the number of moles of HCl. So molarity, remember, it is always in 1,000 centimeters cubed, and we are looking also the number of moles. So 0.04 moles are present in 20, the average titer. So what about in 1,000? So if you want to know the number of moles, you cross multiply and the answer will be 0.2 moles in 1,000, meaning the concentration or the molarity of the HCl was 0.2 m. Calculate the concentration of the acid in grams per dimeter cubed. So in dimeter cubed, which can also be written this way, it is a grams per liter or grams per 1,000. So from E above, we know 0.2 moles are there in 1,000, the meaning of 0.2 molarity. Therefore, we are required to change the number of moles into grams. So how do we do it? We know the molar mass of HCl is 36.5 after addition of the relative atomic masses. So now what about 0.2 moles? So we place our 0.2 on the mole side. We do a cross multiplication, 0.2 times 36.5 divided by 1 mole, the mole cancel and the mole cancel to get a value of 73 grams per dimeter cubed. So that is the concentration in grams per dimeter cubed. These are very common question in titration, and I hope the concepts are clear. There's a quiz here to quiz yourself, and in this quiz we just require you to use examples we have worked out to test your understanding and accuracy. So try to work it out and understand and internalize the concepts. Differentiate between when you want to know the equation and also during the standardization. Thank you. Let's meet in the next lesson.